Good morning, everyone. Today we will start our new chapter, that is chapter number 2 of Geography, Land, Soil and Water. Here are the synopsis of this chapter: introduction of land, then in land use, landslide, conservation of land. Then after, foremost important topic is soil, then factors, layers, types, method and conservation, and at last main topic is water, and in water, distribution of water, problem of water availability, and conservation and management of water. So let's first start with land. Meaning of land. Economic is a science of everyday life. It has to use words of everyday language, but it gives them a meaning of its own, sometimes narrow and other times wide. The term value, for an example, has given a narrow meaning and land a very wide one. By land is meant not merely land in the strict sense of the word, but whole of the material and forces which nature gives freely for man's aid in land, water, in air, light and heat, by Dr. Marshall. In economics, the word land is used not merely in the sense of the soil or surface of the earth, as it ordinarily understood is stand or for all nature, living and lifeless. It includes all natural resources that we can get free from air, water and land. It covers the land surface, whether level or mountainous. It includes ocean, lakes, river, mineral deposit, rainfall, water power, fisheries, forests, and numerous other things which nature provides and man uses. The term land thus embraces all that nature has created on the earth, above the earth, and below the earth's surface. According to Dr. Marshall, has therefore defined land thus by land is not merely land in the strict sense of the word. The actual importance of the land is based on the factor of production is of immense importance. As has already been pointed out, everything that we use can be traced ultimately to land. Land may be rightly called the original source of all material wealth. The economic prosperity of a country is closely linked with the richness of her natural resources. Next point is importance of land. Land as a factor of production is of immense importance. It is true to say that a country is what nature has made it. It is possible that a country rich in natural resources may certain poor, owing to some unfavorable factors, but if nature has been unkind and has not given rich resources to a country, it will not be easy to make it prosperous. Obviously, the quality and quantity of agricultural wealth in a country depends on the nature of the soil, climate and rainfall. Agricultural product in their turn from very basis of trade and industry. Industrial prosperity further depends on the presence of rich coal mines or waterfalls from which electricity can be generated. Localization of industry depend on the proximity of power and raw materials, and they are largely determined by nature. Thus, all aspects of economic life, agriculture, trade and industry are generally influenced by natural resources, which basically belongs to land. Land or nature has a determining influence in modeling the life, occupation and standard of living of a people. Next point is uses of land. Land use involves the management and modification of natural environment or wilderness into built environments such as settlements and semi-natural habitats such as arable fields, pastures and managed wood. Basically, land use is based upon recreational, transportation, agricultural, residential and commercial. So my first question is, how is land useful to us? The land is used for human development like plantation of industry, implementing many roads. This land is also used for planting trees that save the environment and protect us from ecological imbalance. This land is also used for cropping. Great dams are constructed on the land to save water. Next foremost topic is landslide. Landslides are mainly caused by gravity acting on weakened rocks and soil that make up a sloping area of land. Both natural and human-related activity can increase the risk for landslide. Water from heavy rainfall is a frequent trigger for landslide. It is based upon natural and human causes. Human intervention has played a key role in stimulating the natural accidents of landslide occurring in these study areas. It is concluded that risk perception has not been wide enough to promote adequate risk mitigation, in part because of a failure properly to conceive of landslide as polycausal phenomena in which man-made causes effectively cannot and should not be separated from natural ones. Conceptual equations are presented for the net benefits, total risks, and total vulnerability associated with hazard zone occupation. It is shown that as they are polycausal phenomena, landslides require a more sophisticated approach to this form of analysis than that employed for most other forms of hazard. Landslide occur when the slope or a portion of it undergoes some processes that change its condition from stable to unstable. This is essentially due to a decrease in the shear strength of the slope material to an increase in the shear stress borne by the material or to a combination of the two. A change in the stability of a slope can be caused by a number of factors acting together or alone. Natural causes of landslide include saturation by rainwater, rising of groundwater or increase of pure water pressure, increase of hydrostatic pressure, loss or absence of vertical vegetative structure, soil nutrients and soil structure, physical and chemical weathering, ground shaking caused by earthquake, and many more. Landslides are aggravated by human activities, for an example like deforestation, cultivation and construction, vibration from machinery or traffic, blasting and mining, earthwork by altering the shape of a slope or imposing new loads. In shallow soil, the removal of deep-rooted vegetation that bind colluvium to bedrock, agricultural or forestry activities also. Last topic of land is conservation of land. Land conservation is the process of protecting natural land and returning developed land to its natural state. Preservation is when lands and their natural resource should not be consumed by humans and should instead to be maintained in their pristine form. So my first question is, why do we conserve land? Natural and agricultural land are vital for every water quality and supply of our wildlife and our tourism. This land support us, they provide for and clean our water and maintain flood control, storm protection, recreation, etc. Land conservation isn't it an amenity value, it is vital or based on a per future scenario. Our next question is, what are the methods for conservation of land? Giving protection to animals and plants species, restoration, alternative energy, rewilding, natural reserve and zoos, recycling and education are the some method to conserve or to protect our land. Our next foremost topic is soil. What do you mean by soil? A soil is a mixture of organic matter, mineral, gases, liquids and organisms that together support life. Earth's body of soil called the pedosphere, which has developed in the uppermost layer of the earth crust. Soil is one of the principal substrata of life on earth, serving as a reservoir of water and nutrient, as a medium for the filtration and breakdown of injurious waste, and as a participation in the cycling of carbon and other elements through the global ecosystem. It has evolved through weathering process driven by biological, climate, geologic and topographic influences. My first question is, how soil is formed? The soil has taken thousands of years to form. Soil formation takes place in the following ways. Big rocks break down into smaller rocks by continuous action of wind and rain. Rocks are mainly broken by two types of weathering, physical weathering and chemical weathering. A number of natural forces called agents work to break down the parent rock into tiny particles of soil. These pieces get further broken down to form sand and silt and ultimately into finer particles, and the process continues. This process is very slow. It will take thousands of years to form just 1 centimeter layer of soil. These particles form the top layer of the soil. Let's start with layers. The first part of the soil is called horizon A or topsoil. It is also called the humus layer, which is rich in organic material. This layer consists of decomposed material and organic matter. This is the reason the topsoil has a dark brown color. The humus makes the topsoil soft, porous to hold enough air and water. Many living organisms like earthworm, millipedes, centipedes, bacteria and fungi are found in this layer of soil. Second is horizon B or subsoil. Just below the topsoil lies another layer called subsoil or horizon B. It is comparatively harder and compact than topsoil. It is lighter in color than the topsoil because there is less humus in this layer. This layer is less organic but is rich in minerals, especially iron oxide in a large proportion. Farmers often mix horizon A and horizon B when plowing their fields. Third is horizon C, bedrock. Bedrock is also known as parent rock and lies just below the subsoil. It contains no organic matter and made up of stone and rock, so it is very hard. This layer represents a transition zone between the Earth's bedrock and horizon A and B. So my question is, what is humus layer in the soil? Humus layer in the soil is called topsoil or horizon A, which is rich in organic material. This layer consists of decomposed material and organic matter. This is the reason the topsoil has dark brown color. After layer of soil, types of soil. India being abode to various climatic zone and condition, the soil found here of vivid range too. Below are the various soil found in India in the descending order or its coverage or occupancy. First is alluvial soil. This type of soil is mostly segregated by to the river drainage system in India and rich in potash, humus with bit nitrogen. Red soil and yellow soil. These soil are formed by weathering of the ancient crystalline and metamorphic rocks. Their color is red due to high iron content. They cover 8.5% of Indian landmass or are well rich in iron and potash but poor in nitrogen, phosphorus and humus. Black soil. Black soil is also called rigor soil. These soil are rich in potash, iron, calcium, alumina but poor in nitrogen, phosphate and humus. Water retaining capacity is high due to clay texture and thus are very suitable for crops like cotton. This soil occupy almost 15% of Indian crust and are found in Deccan Plateau region, covering Maharashtra, Telangana, Karnataka and a small portion of Andhra, Chota Nagpur Plateau, etc. Mountainous soil. Forest and mountainous soil by namesake are found in mountain region at high altitude. Most of Jammu and Kashmir, Sikkim and the other parts of Himachal Pradesh, Uttarakhand and Arunachal Pradesh, etc. The texture of mountain soil can be loamy, clayey, alluvial, etc. and depends on the mountain region and climate. It covers 8% area of Indian subcontinent. This soil is basically suitable for tea and fruit cultivation. Laterite soil. This soil are rich in iron and aluminium and is commonly considered to have formed in hot and wet tropical areas. They were developed under extreme and prolonged weather conditions of parent to rocks. High iron oxide and aluminium and lack of phosphate, potash and nitrogen. Humus this soil are not favorable for agriculture but are mostly used for baking bricks. Arid. These are sandy soil found in desert area of India in Thar desert of Rajasthan. These are not suitable for agriculture. Next, foremost important topic is degradation of soil and methods of soil conservation. Soil conservation is the name given to a handful of techniques aimed at preserving the soil. Soil loss and loss of soil fertility can be traced back to a number of causes including overuse, erosion, salinization, chemical contamination, unsuitable subsistence farming, and the slash and burn clearing method. used in some less developed regions can often cause deforestation, loss of soil nutrient erosion on a massive scale, and sometimes even complete desertification. Soil erosion removes the topsoil that is necessary for organic matter, nutrients, microorganisms that are required for plants to grow and shine. Soil conservation is one such a step that protects the soil from being washed away. The soil then ends up in aquatic resources, bringing in pesticides and fertilizer used on agriculture land. Method of soil conservation. Afforestation, which means grow more and more trees. Crop rotation. Adopting sustainable agriculture practices is the most important measure to conserve soil. In many parts of India, a particular crop is sown in the same field year after year. Legumes such as peas, beans, and other plants add nitrate to the soil by converting free nitrogen in the air into nitrogenous nodules on their root. Strip cropping. Crop may be cultivated in alternative strips parallel to one another. Some strips may be allowed to lie follow while in other different crops may be sown. The tall growing crop act as windbreak and the strips which are often parallel to the contour help in increasing water absorption by the soil by slowing down runoff. Contour plowing. If plowing is done at right angle to the hill slope, the ridges and furrows break the flow of water down the hill. This prevents excessive soil loss as gullies are less likely to develop and also reduce runoff so that plants receive more water. Shifting cultivation. Checking and reducing shifting cultivation but persuading the tribal people to switch over to settled agriculture is a very effective method of soil conservation. This can be done by making arrangement of their resettlement which involve the provision of residential accommodation, agriculture implementation, seeds, manures, cattle and reclaimed land. Mulching. The bare ground topsoil between plant is covered with a protective layer of organic matter like glass, clippings, straw, etc. What is the actual benefit of mulching? It protects the soil from erosion. It helps to retain soil moisture. It reduces compaction from the impact of heavy rain. Contour barrier. Stone, grass, soil are used to build barrier along contour. Trenches are made in front of the barrier to collect water. A long-term advantage of barrier is that soil tend to build up behind them, creating a trace effect. Barrier can be classified as dead crops, residues, or mixed, a combination of the previous one. Rock dams. Rocks are piled up across a channel to slow down the flow of water. This prevents gullies and further soil loss. Terrace farming. In terracing, a number of terraces are cut along the hill slope. These are made on the steep slope so that flat surfaces are available to grow crops. Our last topic is water. Water is a substance composed of the chemical elements that is hydrogen and oxygen and existing in gaseous, liquid and solid state. It is one of the most plentiful and essential of compounds. A tasteless and odorless liquid at room temperature, it has the important ability to dissolve many other substances. It is an inorganic, transparent, odorless and nearly colorless chemical substance which is the main constituent of Earth's hydrosphere and the fluid of most living organisms. It plays a vital role in everybody's life. In water, next topic is distribution of water on Earth. The distribution of water on the Earth's surface is extremely uneven. Only 3% of water on the surface is fresh. The remaining 97% reside in the ocean. Of fresh water, 69% resides in glacier, 30% underground, and less than 1% is located in lake, river, and swamps. Our next topic is problems of water availability. Water scarcity is the lack of fresh water resources to meet water demand. It affects every continent and was listed in 2019 by the World Economic Forum as one of the largest global risks in terms of potential impact over the next decade. It is manifested by partial or no satisfaction of expressed demand, economic competition for water quality, quantity, disputes between user, irreversible depletion of groundwater, and negative impact on the environment. Two-thirds of the global population live under conditions of severe water scarcity at least 1 month of the year. Half a billion people in the world face severe water scarcity all year round. Half of the world's largest cities experience water scarcity. Many of people have problems with water scarcity. The essence of global water scarcity is the geographic and temporal mismatch between freshwater demand and availability. The increasing world population, improving living standard, changing consumption pattern, and expansion of irrigated agriculture are the main driving forces for the rising global demand for water. Conservation of water, and what are the actual methods to adopt to preserve or to preserve our water resources. Water is indeed an essential resource for life on earth and it must be conserved. In fact, historically humans had learned to conserve available water resource by building dams. Dams are simply hydraulic structures that act as a barrier between the source and the destination of flowing water. Earlier these dams were small and handmade. In our modern society, engineering technique and method are used to construct most of these dams. Rainwater harvesting and another method to conserve water. You must have come across this term from multiple media sources. Rainwater harvesting is one of the most efficient and effective ways of conserving water. It is more like recycling of natural water. In this, the rooftop rainwater harvesting is a common practice in states like Rajasthan, West Bengal, Meghalaya, and major part of South India, where rainfall is usually heavy. People connect PVC pipe to a drain on their roof, and the rainwater is collected below in large storage tanks. This water is then utilized for daily needs even after rain are over. Most people do not collect the water of first rain, but are thereafter in Shillong and other parts of Meghalaya and rain-prone region of northeast, water from rooftop rainwater harvesting covers about 15 to 25% of household water requirement. Bamboo drip irrigation system. This is an indigenous method which has been in practice for about 200 years in the northeastern states of India. While this practice helps conserve the region's water resources, it also helps in irrigation of local farm and field. People use bamboo pipes for tapping the water of streams and springs. About 18,020 liters of water flow through a network of pipe and end up as a drip on the farmland. Thank you everyone. This chapter is over.